In this topic we are going to study grouping of cell. Cell is an electrochemical device which produces electrical energy to a circuit, and cell you can say is a energy provider, and its symbol is, we know, its symbol is two parallel lines. One is longer, which actually represent terminals. These are actually electrode, positive terminal and negative terminal. So this is the symbol of a cell. And in a previous lecture we have studied about the EMF of cell, and cell have internal resistance as well, and it is represented like this. So this is a symbol of cell. In many cases actually we need more power and higher EMF, so we join cell in a group. So cells are joined in two ways. Grouping of cell are joined in two ways. First is called series combination, and second is called parallel combination. Series and parallel combination are very similar to that series and parallel combination of resistor and capacitor. So if I join cell like this is series combination, and if I join cell like this this is parallel combination of cell. One more thing, a group of cell connected either series or parallel, they provide more energy to a circuit, and this grouping of cell is called battery. So battery is a group of cells. So we can say group of cell is called battery. So this is battery, and this single is a cell. So this is the big difference between cell and battery. Here first we are going to study series combination of I have taken three cells. In series, whose EMF is E1 and internal resistance is R1, and its EMF is E2, internal resistance is R2, and this is E3 and R3. Without proof right now, I am going to tell you that this combination of three cell can be replaced by a single cell with polarity. The first left hand side is positive terminal and then negative. So in series combination, cells are joined like this, that negative terminal of one cell is connected to positive terminal of the other, and its negative terminal is connected to the positive terminal of the next. So this is series combination. And in series combination as well, the polarity of any cell can be reversed as well. We will see it soon. So this cell is called equivalent cell or battery. So its net EMF is equivalent and R equivalent. So E equivalent here is E1 plus E2 plus E3, and R equivalent will be R1 plus R2 plus R3. So this three cell is replaced by a single cell, and if this cell is connected to our external resistance, we can easily calculate the current or whatsoever is asked. Suppose this is connected to an external resistance R, and current is asked. So I will be equal to, in the R plus R equivalent. So this three cell if connected to resistance. First we will replace this 3 cell with equivalent, and then we will solve the circuit to find the current. If the polarity of any cell is reverse, suppose first cell is this and second is this and third is reverse, suppose I have a 4 cell, this, suppose this is E1 R1, E2 R2, E3 R3, E4 R4, and I am going to replace this cell like this: R equivalent, E equivalent. So you see the polarity of the resultant cell. In the left side we have shown a positive terminal, so positive terminal is left side in the resultant. So this cell which have left side positive terminal will be treated as a positive, so E equivalent can be written as E1 plus E2 but minus E3 plus E4. Why so? Because I have drawn positive terminal of the resultant equivalent cell to the left, so all the terminal whose positive terminal left side will be taken positive and this will be taken negative, so there is E3. But in case of equivalent resistance there is no positive or negative side of resistance, so it will be always added like this. But if I replace this cell, this group of cell like this, so E equivalent and R equivalent. Again E equivalent we have negative terminal, so this will be taken positive, so E3 minus E1 minus E2 minus E4, while R equivalent will be R1 plus R2 plus R3 plus R4. there is no positive negative sign with resistance. So if I have a circuit, suppose this is E1, E2, E3, R1, R2, R3 and this is R. If I replace equivalent resistance like this, then I have right side of the cell as a positive terminal, so this cell will be positive while this cell will be negative, so equivalent EMF will be E3 minus E1 minus E2, while R equivalent will be equal to R1 plus R2 plus R3. So current will flow this way and its value will be E equivalent upon R plus R equivalent. So I have taken positive terminal to the right side, so current will flow like this and current will be this. Suppose this come out to be negative, what does it mean? If E equivalent is negative, it means current is negative, and current negative means the direction of actual current is opposite to the zone 1, I mean the zone direction is clockwise, and if I is come out to be negative, it means the current will flow to the anti-clockwise direction. Now I'm going to take a general case. Suppose I have n cells in series, E1 R1, E2 R2, En Rn, and connected with an external load capital R. So this can be replaced by equivalent cell whose equivalent EMF is E equivalent and internal resistance is R equivalent. And what is the meaning of equivalent cell? Actually, this group of cell, which is called battery, this provide the same current in that resistor, which and this equivalent cell will provide the same amount of current in this same external load. This way this cell will be called equivalent cell of grouping of cell, because it provides the same current to the external load, so the voltage across the external load will be the same as here, same current, same voltage across the external load. So this equivalent EMF will be equal to E1 plus E2 plus En, and this can be written as summation of EI, and R equivalent equal to R1 plus R2 plus some Rn. This can be written as summation of Ri. So current will be E equivalent plus R equivalent. In case all cells are identical means E1 equals to E2 equals to En, and let's say it equal to E. Similarly R1 R2, this R equal to Rn equal to R. In that case I can be written as E equivalent upon R plus R equivalent, and we know that this is summation of EI upon R plus summation of Ri. So this equal to Ne, and that equal to R plus Nr, because E equivalent equal to E plus N times, and that equal to so we have E equivalent equal to E plus E N times, because we have N cell and all identical, so this equal to Ne, while R equivalent equal to R plus R, and this also N times, so that's equal to Nr. So we have that much current in the circuit. Here we have three cells in series. With the polarity as shown, and we have equivalent cell of these three cells. So equivalent means these three cells provide the same current as the single cell to the same external load, so same current. So if I applying Kirchhoff voltage law, KVL Kirchhoff voltage law to this circuit, applying KVL to this circuit, to this circuit, we have delta V equal to 0, I mean IR, there is a drop, minus IR here, minus IR, and if I go to this, then this resistor, then this, we see we are moving along the direction of current. So if I go across a resistor, we have a drop of potential, I mean there is a drop of I R3, while there is a rise of potential, so there is a change plus E3, and similar to the other. So we have I R3 plus E3 minus I R2 plus E2 minus I R1 plus E1, and that's equal to 0. So this can be written as I R plus R1 plus R2 plus R3 equals to E1 plus E2 plus E3. In if I same principle apply here, we can write minus IR equivalent plus E equivalent equal to 0. So I come out to be E equivalent upon R plus R equivalent. Well, what about here for I, for this group of cell, I equal to E1 plus E2 plus E3 whole upon R plus R1 plus R2 plus R3. So comparing these two equation, we can write that E equivalent is E1 plus E2 plus E3, while R equivalent is, we see this is R equivalent and it is equal to this one, because R is same here, so rest is R equivalent, so this equal to R1 plus R2 plus R3. Here we have three cell, E1 with internal resistance R1, E2 with internal resistance R2, and these are connected in parallel, and their equivalent is here E equivalent and R equivalent. They provide the same current to external load R, that's why they are this is equivalent, is called equivalent cell of these three cell. How to find, first of all I would like to tell you how to find these E equivalent and R equivalent, then I will prove, I will drive how to get this one, but without proof, first of all I would like to write down what the expression to find R equivalent and E equivalent. These three cell internal resistance are treated to be connected in parallel. So first of all R equivalent is obtained same as we get the equivalent resistance for resistance connected in parallel, that 1 upon R1 plus 2 plus 1 upon R3. So this can be written as 1 upon Ri in case of parallel combination. And how to find E equivalent, the expression is E equivalent upon R equivalent is equal to summation of EI Ri. I mean in that case it is E1 by R1, E2 by R2 plus E3 by R3. So to get E equivalent, we have to obtain E R equivalent first and to get this one. So this is the formula to we remember all the time, that R equivalent is equal to summation of 1 upon Ri, and E equivalent upon R equivalent equal to summation of EI upon Ri. So this formula is to be remember. in case of parallel combination. And now how to find the current in the circuit. The current in the circuit I equal to E equivalent upon R equivalent, R plus E R equivalent, where we know how to find E equivalent and R equivalent. So we are going to take some example over. So in this problem we have to find the current through the load resistance I. So we have two cells in parallel. So I would like to replace this two cell with a single cell whose internal resistance is R equivalent and EMF is E equivalent, and the load resistor is 9 ohm. So first of all we are going to find R equivalent first. So R equivalent is, we have two resistance in parallel, 1 by R1, 1 by R2. So this equal to 1 by 2, this equal to 1. So R equivalent is equal to 1 ohm. So this equal to 1 ohm, and E equivalent upon R equivalent equal to E1 by R1 plus E2 by R2, and that's equal to 10 divided by 2 plus 20 divided by 2. There is a division of EMF with its respective internal resistance. So it is 20 by 2, that's come out to be this 5, and this is 10. So this come out to be 15. And E equivalent by R equivalent we know is 1 ohm here. So this equal to 15. So E equivalent is equal to 15 volt. So we can now replace this circuit as a single cell with its internal resistance 1 ohm and this 15 volt, and external load as before 9 ohm. So current I equals to 15 upon 9 plus 1, I mean 1.5 ampere. So this way we can easily solve. Otherwise there's another method we can apply here, and it is Kirchhoff voltage law. We can assume there's a current I1, there's a current I2, and there's this current equal to I1 plus I2, and apply KVL in two circuit, because there's two unknown I1 and I2, and you can find the current. Now we have three cells in parallel, but one cell, this one, with reverse polarity, because in these two cells have positive terminal connected with the negative terminal of the third one. If these three cells are represented by this equivalent cell, E equivalent and R equivalent, and its polarity matches with these two, so how to find this one? First of all, as I've told you, for R equivalent is always like this, 1 upon R1 plus 1 upon R2 plus 1 upon R3. But for E equivalent upon R equivalent equal to E1 upon R1 plus E2 upon R2, but minus E3 by R3, because the equivalent polarity matches with these two but in opposite with this, so we have negative sign. But if I replace these three cell with an equivalent cell like this with the polarity opposite to that, in that case what will be the change? So R equivalent is as before, 1 upon R1 plus 1 upon R2 plus 1 upon R3, but E equivalent by R equivalent is equal to, now this matches with this cell, so this will taken in the positive, so E3 by R3 minus E1 by R1 minus E2 by R2. Suppose this expression come out to be positive, this come out to be positive, it means that polarity of the cell if is taken, that will be advisable, I mean this will be good, and if this come out to be negative, then the polarity should be reverse. Here we have n cells in parallel, with the, and these cells are not identical, but one thing I have taken that their positive terminals are all connected together. So this n cell is replaced by an equivalent cell with R equivalent and E equivalent, so 1 upon R equivalent can be written as 1 upon R1 plus 1 upon R2 up to n times, so this can be written as 1 upon R equivalent equal to summation of 1 upon Ri, and E equivalent upon R equivalent equal to E1 upon R1 plus E2 upon R2 sum n times En upon Rn, so this can be written as E equivalent upon R equivalent equal to summation of Ei by Ri. So these two formulae are worth remembering. And if cells are identical, what happen if n cells are identical cells, I mean R1 equal to R2 equal to Rn, these are equal to R, and E1 equal to E2 equal to, these are all equal to En and equal to E. In that case we have to find R equivalent and E equivalent, so 1 upon R equivalent equal to 1 by R n times, so this equal to n by R, hence R equivalent equal to R by n, and E equivalent upon R equivalent equal to E by R n times E by R, and that's equal to Ne by R, and we know R equivalent is how much, R by n, so E equivalent upon R by n equal to Ne by R, so this equal to Ne equivalent by R equal to Ne by R, R will cancel out, n will cancel out, so E equivalent equal to Ne equivalent by R equal to Ne by R, R will cancel out, n will cancel out, so E equivalent equal to E. So if I have a circuit in which I have 3 cells and these cells are identical, same EMF and same internal resistance, so R equivalent equal to R by n, here R is 3 ohm by 3, there's 3 cell 1 2 3, so this equal to 1 ohm, and E equivalent equal to EMF of either cell, which is 10 volt, 10 volts. So these 3 cell can be replaced like this by a single cell whose internal resistance is 1 ohm, and EMF is EMF of either cell, I mean 10 volt, and it's connected to an external load which is 4 ohm. So we can find current easily in that. I equal to 10 volt upon 1 plus 4, I mean 2 ampere. We have a 2 cell whose EMF is E1 and E2 with internal resistance R1 and R2, and this is connected with the load resistor R. Now we have draw an equivalent cell whose EMF is E equivalent and internal resistance is R equivalent. In what condition this single cell will called equivalent cell of these two cells? If this external load takes same current that which it obtain from a group of two cell, same current, then in every respect this single cell will be equivalent to this two cell, because same current flow through the resistor in that case and in that case also. So potential difference across the load resistor in first case and in second case will be the same. Suppose there is a current I1 in that branch and I2 in that branch. So we can write I1 plus I2 equal to I. And if this is terminal voltage, this is potential difference across this resistor R. So these three branches are in parallel, so same potential difference will occur across the three branches. So we know from us for a cell that if this is a cell and its EMF is E and R is internal resistance and there is a current I, so terminal voltage V equal to E minus IR. So I can be equal to E minus V by R. So in that case I here can be written as E minus V upon E upon so this equals to R equivalent. So for this first cell I1 can be equals to E1 minus V upon R1, and I2 can be equal to E2 minus V upon R2. So putting in that equation, since I1 plus I2 equal to I1 can be equal to E1 minus V upon R1 plus E2 minus V upon R2, and I can be written like that E minus V upon, and this is actually E equivalent, this is E equivalent upon R equivalent. So this equation can be written as E1 by R1 minus V by R1 plus E2 by R2 minus V by R2 equal to, this can be written as E equivalent upon R equivalent minus V 1 upon R equivalent. So this can be written as E1 by R1 plus E2 by R2 minus V 1 upon R1 plus 1 upon R2, and that's equal to E equivalent upon R equivalent minus V 1 upon R equivalent. Comparing from left side with left side with right side, comparing, we get E1 by R1 plus E2 by R2 equals, so this equals to that much, equivalent upon R equivalent, and there is this equal to this, so 1 upon R1 plus 1 upon R2 equal to 1 by R equivalent. That was to be proved. Here we have a mixed combination of cell. Mixed means series and parallel, both combination. So we have identical cell here, identical cell, each of EMF E and resistance R. So we have that branch in which there's n cells in series, and there's a m parallel branch. So there's n cell in one branch and there's m such parallel branch, so their number of total cells equal to mn. Now this is connected to a external load, R. So this series combination of cell where there is n cell can be replaced by a single cell whose EMF will be NE and internal resistance NR, because all these resistors are in series, so NR, and there are m such branches. There are m such branches. So each branch can be represented like this, that is, its EMF is NE and internal resistance is NR, and this is connected with a external load. So this is R. Now so these cells in parallel and this cell are identical because each have same EMF and same internal resistance. So this can be replaced by a single cell. Since EMF is same, in that case same EMF will be applied irrespective of number of branches, so EMF is NE, but these resistors can be considered to be connected in parallel, so NR upon M, because there is M branches and there is a external load R. So how much? So this is what a equivalent cell out of this cluster of resistor. So how much will be the current here? Current here will be net EMF NE upon total resistance. So this resistor and this internal resistor are in series, so R plus NR upon M. So this can be written as I equals to NE upon MR plus NR, and M will be there, so MNE upon MR plus NR. So this is the current drawn from the equivalent cell. Now we are going to explore what is the condition when this current will be maximum. For this has to be minimum. minimum. What is the condition? We are going to explore the condition in which this term will attain minimum value. Now we know that a plus b can be written as root a minus root b whole square plus 2 root ab. So this can be written as mne upon root mr minus root nr whole square plus 2 root mr into root nr. So this is the expression for I. This term has a square as a power, as a indices, so its minimum value will be 0, and when this will attain 0, this I will be maximum. So when I becomes maximum, root mr equal to root nr, and this can be written as mr equal to nr. So r equal to nr by m, and this was the internal resistance of equivalent cell. So this current will be maximum. So this current will be maximum when this resistance will be equal to this one. And how much this current equals to? Imax will be equal to mne upon this is taken 0, so this will be equal to 2 root mr root nr, and these two terms are equal also, so that can be written as mne upon 2 root mn r and r. So if this equals to, if these two terms are equals, so if this can be replaced by root mr, so this can be equal to mne upon 2 mr. M will cancel out, so this equal to ne upon 2r. We have two cell X and Y, so this is X and this is Y, are connected to a resistor of 10 ohm. So this is 10 ohm as on terminal across Y, terminal voltage across Y. So this two cell can be written as, I redraw it, and we have 10 ohm, and this is 6 volt, 2 ohm, 4 volt, 8 ohm. So this is X and this is Y. So these are in series. So current will be total EMF E1 plus E2 upon R plus R1 plus R2. 6 plus 4 upon 10 ohm and 10 ohm. This is 10 ohm plus 2 plus 8. So we have 10 volt and 20. So this is 1 by 2 ampere. Now for this cell current is coming out like this. Current direction is this one. So terminal voltage is E minus IR. Remember one thing, if a cell is like this and current come out like this, so terminal voltage is E minus IR, while if current goes into the cell, terminal voltage is E plus IR. So here it is for Y cell. E is 4 volt minus I is same for both, 1 by 2, and internal resistance is 8. So this is 4 minus 4, 0 volt. So answer will be 0 volt. This is the answer. In the following circuit, VA minus VB is 4 volt, means potential difference between these 2 points. This is VA and this is B, and in this is A and this is B as well. So we have given 4 volt and we have to find X. So let this is 5 volt and this is 2 volt. So this is greater, so current assumed to flow this way. Let it is I. So I will be equal to 5 minus 2, because the polarity of these two are just it try to draw current this way while this way, so these are opposite, so that's why they are subtracted. And 10 ohm plus X, so this is 3 upon 10 plus X. So this is the current. And potential, if I go from B to A, we can write VB plus 5 minus IR, because if I go along the current there is a drop. VB minus plus 5 minus 10I equal to VA. So this can be written as 5 minus 10I equal to VA minus VB, and that is given 4 volt. So this is 4 volt. So 5 minus 10I equal to 4. So 10I equal to 5 minus 4, 1. So I equal to 1 by 10, but I is 3 upon 10 plus X. 3 upon 10 plus X. So this equal to 10 plus X equal to 30. So X equal to 20 ohm. X equal to 2 ohm. So this is the answer. Two cells, two battery of EMF E1 and E2 and internal resistance R are in parallel. They determine their equivalent EMF. We know that if we have two cells in parallel, this is R1, this is R2, and EMF is E1 E2. So their equivalent resistance 1 upon R equivalent is 1 upon R1 plus 1 upon R2, and E equivalent upon R equivalent equal to E1 upon R1 plus E2 upon R2. Hence E equivalent will be equal to R equivalent E1 by R1 plus E2 by R2. We know this can be written as this is R1 R2, R1 plus R2, and this equal to 1 by R equivalent. So R equivalent will be equal to R1 R2 upon R1 plus R2. So we can put it here. This equal to R1 R2 upon R1 plus R2, and these terms can be written as E1 R2 plus E1 E2 R1 upon R1 R2. So this term will cancelled out, and we have E1 R2 E2 R1 upon R1 plus R2, and that was to be proved here. So we have to find the current through 10 ohm resistor. We have these two cells and these are in parallel, so I can redraw this as we have two cell in parallel and the load resistor 8 ohm. So cells are in parallel, so this is 8 volt and this is 6 volt, and internal resistance are 4 ohm and 6 ohm, 4 and 6 ohm. So this can be replaced by a single cell, and this is load resistor 8 ohm, and this is R equivalent, E equivalent. So R equivalent and these two resistors internal resistance are in parallel, so this can be written as 4 into 6 upon 10. I can write as 2 5, so this is 12 by 5 ohm, and E equivalent upon R equivalent equal to E1 upon R1 plus E2 by R2. So E1 by R1 8 by 4 and 6 by 6, so this is 2 plus 1 means 3. So E equivalent equal to 3 into R equivalent, 3 into 12 by 5, 36 by 5 volt. So current in that I will be equal to net EMF E equivalent upon R plus R equivalent, and E equivalent is 36 by 5 whole upon 8 plus R equivalent is this much, 12 by 5. So this can be equal to, this will equal to 36 by 5 and 52 by 2, so this equal to 36 by 52 ampere, and we can simplify it, and that equal to, and this equal to 0.69 ampere. So this will be the answer. Now the question is 100 cells each of 5 volt and internal resistance 1 ohm are arranged so that produce maximum current in 25 ohm resistor. Each row is to contain equal number of cell. Number of rows should be, this is the question. Now we know that if we have n cell in series and there's m branches, so number of cell is mn, and m is equal to 100 volt, and EMF is 5 volt as given, and internal resistance small r is 1 ohm. Now the capital R is 25 ohm. So to obtain maximum current, the condition for maximum current is this resistance should be equal to this one. So we have N R by M equal to 25. So N by M into 1 ohm equal to 25. So N equal to 25 M, and we have Mn equal to 100. So how to solve this? Mn equal to 100. So we have these two equation. We can put the value of n here. So M and n equal to 25, M equal to 100. So M square is equal to 4. So M equal to 2. So number of branches is 2 and number of rows means branches is 2. So this is the answer. We have two independent resistors R1 and R2 to be connected with a cell of constant EMF in turn, and the same amount of which is dissipated in equal interval of time for two cases. Then internal resistance of cell is. It is given that this is two cases, case 1 and case 2, and the power, it is said that heat is equal amount of heat is dissipated in equal time of interval. The power is same in these two cases in the load resistor R1 and R2. So power is, how to find power? Power is equal to I square R. So I square R in this case and in that case will be equal. So how to find current? Current, for to finding current is I equal to E upon R plus R. So power in first case will be E upon R1 plus R whole square into R1 for the first case, and second case E upon R2 plus R whole square into R2. So this is the power, and we have to equate this. Now we will going to find the small r. So this can be written as E square R1 upon R1 plus R square. E square R1 upon R1 plus R whole square, and this equal to E square R2 upon R2 plus R whole square. So E square will cancel out, and we have to cross multiply R1 R2 plus R whole square R2 R1 plus R whole square. So this can be written like this: R1 R2 square R square 2 R2 R is equal to R2 R1 square R square 2 R1 R, and that equal to R1 R2 square R1 R square 2 R1 R2 R, and that equal to R2 R1 square plus R2 R square plus 2 R1 R2 R. So this cancelled, and we know we have to find small r. So they have to place one side. So this can be written as R1 R square minus R2 R square equal to R2 R1 square minus R1 R2 square. Take R1 R2 common, so this is R1 minus R2, and here R square equal to R1 minus R2, that equal to R1 R2 R1 minus R2. So small r equal to R1 R2. So this is the answer that so D answer is correct. D answer. N rows is containing M cells in series are joined in parallel. Maximum current is taken off from this combination in a 3 ohm resistor. If total number of cell used is 25 and internal of each cell is 25.5, find the value of Mn. So the equivalent circuit for this mixed grouping can be written as ME, and internal resistance is this much, and number of cells, total number of cells we know is Mn, and it is given as 24. And for maximum current in that resistance R will be equal to internal resistance of cell. So R equal to Mr by N, where M is number of cells in one branch, and there is N rows containing M cell. M cell is given here, M cell in series. So and this capital R is given as 3 ohm. So M and R is 0.5 upon N equal to 3. So this equal to M by N equal to 6 and Mn equal to 24. So we have this as first equation and this is second equation. If I multiplied these two equation, I mean Mn into M by N, it equal to 24 into 6. So M square equal to 24 into 6. So that equal to 144. So M equal to 12. Now putting value of M here, we can obtain 12 by N equal to 6, so N equal to 2. So we have obtained the value of M and N.